We're going to continue our study on transformations today by talking about a specific type of transformation called dilations. So what is a dilation? A dilation is a transformation that stretches or shrinks a preimage to create an image. Now every dilation has a center of dilation, which is the fixed point that the dilation comes from, and a scale factor, which is the ratio of a side length of the image to the corresponding side length of the preimage. Now, when a preimage is dilated, every line segment in the image is either longer or shorter, depending on a ratio given by the scale factor. How do you find out what the scale factor is? Well, the scale factor is always going to equal the side length of the image divided by the corresponding side length of the preimage. So the side length of the resulting image divided by the side length of the original image. Take a look at example 1. Determine the scale factor of the dilation shown below. How do we find the scale factor? Well, we're going to take the side length of the image, so E prime, F prime, G prime, H prime, divided by the side length of one of the sides of the image, so the original one. So we're going to take the length of the side of the image, so the resulting image, E, F, G, H prime, and then we're going to divide it by the length of the corresponding side that's in the preimage, in the original image. So that's E, F, G, H. So let's say, for example, we take the top side, FG. So we need to find the length of F prime G prime and divide it by FG. So F prime G prime has length of 2 and FG has length of 4. So this is 2 over 4, which is equal to 1/2. So we would say that the scale factor of this dilation is 1/2. Now the scale factor is going to tell you if the figure shrinks or stretches. You'll see here in example 1 that if the original image is EFGH and the resulting image is EFGH prime, this has shrunk. So if the scale factor is greater than 1, then this will be an enlargement or a stretch. But if the scale factor is less than 1, then this is a reduction or a shrink. Now, how do we perform dilations? So comparing it with the transformations we talked about last time, we want to have an algebraic rule for these dilations. Now, a couple of things before we get to that. For this class, we're only going to perform dilations with a center at the origin at 0, 0. The only thing that we'll need to account for is going to be the scale factor. So we'll use the variable k to stand for the scale factor. Now the algebraic rule for dilations is going to be x comma y transforms into kx, ky. So in other words, you will multiply both the x and the y by the scale factor. Take a look at example 1. Figure GOLD has the vertices 0, 3, 2, 3, 3, 1, and 2, 0. Sketch GOLD and its image after a dilation with a scale factor of 3. So first, is this a reduction or enlargement? Well, because the scale factor is 3 and 3 is greater than 1, we know this is going to be an enlargement. So our rule is going to be 3x, 3y. So now we'll take each point that was in the original image and we're going to multiply both x and y by 3. So 0, 3 becomes 0, 9, 2, 3 becomes 6, 9, 3, 1 becomes 9, 3, and 2, 0 becomes 6, 0. So now we'll go ahead and graph both the preimage and the image. So the preimage, the original, is at 0, 3, 2, 3, 3, 1, and 2, 0. Now the image is at 0, 9, 6, 9, 9, 3, and 6, 0. We'll connect those as well. Now if you compare the preimage to the image, you can see that the image, the resulting image, has been enlarged. Let's do example 2. Figure BEAR has the vertices -10, 8, -4, 6, -2, 2, and -6, 2. Sketch BEAR and its image after a dilation with a scale factor of 0.5. Now, because 0.5 is smaller than 1, we know that this is going to be a reduction. This is going to get smaller. And our algebraic rule is going to be 0.5 times x and 0.5 times y. Now we'll take all the points of the pre-image and apply this rule. You can think of this as multiplying by 0.5, or you can think of this as dividing by 2, multiplying by a half. So -10, 8 becomes -5, 4. -4, 6 becomes -2, 3. -2, 2 becomes -1, 1. And -6, 2 becomes -3, 1. Now we'll go ahead and graph the pre-image. So that would be at -10, 8, -4, 6, -2, 2, and -6, 2. We'll connect those all. And now we'll graph the points of the image. That's -5, 4, -2, 3, -1, 1, and -3, 1. Connect all of those, and there's our resulting image. You can see going from the blue image to the orange one, we have the same shape, but we don't have the same size. And we can see from the blue to the orange, it has become smaller by a factor of 1/2. Let's take a look at example 3. Determine whether the dilation from figure A to figure B is a reduction or an enlargement. Then find its scale factor. Okay, taking a look at figure A, the red one, and figure B, the blue one, going from the red figure to the blue figure, this has clearly become smaller. So we would say that this is a reduction. Now that tells us that our scale factor should be less than 1. How do we find the scale factor? Well, we can do this by picking a point and its corresponding point and comparing the two. So for example, we have a point at 6, 0 for the red figure and at 2, 0 for the blue figure. And then ask yourself, how do I get from 6, 0 to 2, 0? In other words, what do I have to multiply by in order to get from the 6 to the 2? We know that 0 times anything is going to be 0. Well, in order to get from 6 to 2, I would have to multiply by 1/3. And that makes sense because 1/3 is smaller than 1, and we had said earlier that this is a reduction. Look at example 4. You want to create a figure PQRS that is a dilation of figure JKLM. What are the coordinates of S? So we have to determine, because we're not told, what the scale factor is. How do we figure out what the scale factor is? We'll do it the same way as we did in example 3. We'll pick some corresponding points. So for example, we have a point K at -4, 0, and then point Q at -8, 0. So how do we get from JKLM to PQRS? So how do we get from K to Q? Well, what do I have to multiply K by in order to get Q? It looks like we have to multiply by 2. That means our algebraic rule is going to be x and y becomes 2x, 2y. Now, since S is going to correspond with M, we're going to take the coordinates of M and apply the algebraic rule to it. So M is at -1, -2, and if we multiply the coordinates by 2, we end up with -2, -4. So S is at -2, -4, which is here, and we can just connect it and we can see how this completes our figure PQRS.